If the Trans-Andean Railway were an isolated case, one could perhaps dismiss it as a uniquely poorly documented, yet miraculous, achievement. But it is not an isolated case. It is part of a pattern. A global phenomenon of impossible 19th-century engineering that is consistently explained away by the same, inadequate narrative. Turn your attention to the railways of the Swiss Alps. The Gotthard Railway, completed in 1882. It features a 15-kilometer tunnel, built at high altitude through similar granite mountains. The official story is, again, one of dynamite, steam drills, and thousands of laborers. The logistics are just as baffling. The timelines are just as aggressive. The official records are just as vague on the critical how. Or consider the railways built across the Rocky Mountains in North America. The Canadian Pacific Railway, for example. We see the same kind of visual evidence. Massive, precise cuts into mountainsides, soaring trestle bridges, and long, hard rock tunnels. And we hear the same story, heroic workers with basic tools achieving the impossible. When you place the construction photographs from the Andes, the Alps, and the Rockies side by side, the similarities are unnerving. The style of the rock cuts is identical. The design of the tunnel portals shares a common language. The sheer scale of the earthworks, relative to the documented technology, presents the same mathematical problem again and again. Are we to believe that engineers in South America, North America, and Europe, all working independently, at the same time, all invented the same secret techniques for building impossible structures? And that they all, coincidentally, decided not to document these revolutionary techniques? And that they all, independently, relied on the same cover story of heroic manual labor? This is not logical. A more logical explanation is that we are not looking at independent projects at all. We are looking at the work of a single, coordinated entity. An entity with a standardized, advanced methodology for this kind of construction. An entity that operated globally, delivering these finished infrastructure projects to various national governments, while keeping its core technological secrets to itself. The pattern is too strong to be a coincidence. The repeating motifs, the shared logistical impossibilities, and the identical narrative failures point towards a single, hidden hand. The Trans-Andean Railway is not a one-off anomaly. It is a chapter in a global story that has not yet been told. Let us set aside the photographs and the official stories, and focus on the cold, unforgiving clarity of mathematics. The numbers do not lie, and in the case of the Trans-Andean Railway, they scream impossibility. Let's analyze a single component, the caracoles or spiral section of the track. This section uses a series of tight tunnels and switchbacks to climb an extremely steep grade. Let's focus on just one of its tunnels, tunnel number 10. It is approximately 200 meters long, bored through solid andesite rock, which is as hard as granite. A typical single-track railway tunnel of this era would require the removal of about 40 cubic meters of rock per linear meter. So, for this 200-meter tunnel, we have 8,000 cubic meters of solid rock to excavate. The official tool was the steam drill, followed by dynamite. The best-case scenario for a team using a steam drill and dynamite in the 1880s was the removal of about 1 to 1.5 cubic meters of rock per 10-hour shift. This is an optimistic figure, not accounting for altitude, cold, or equipment failure. Let's be generous and say one team could remove 2 cubic meters per day. To excavate 8,000 cubic meters, a single team would need 4,000 days. That's nearly 11 years. To complete it in the recorded timeline of roughly 1 year, you would need 11 teams working simultaneously. But you can only work from 2 ends of a tunnel at once. Perhaps 2 teams at each end? That's still over 2.5 years. The numbers are simply incompatible. And this is for just one, relatively short tunnel. The entire line has dozens. Now, let's consider the steel. A single kilometer of track requires roughly 80 tons of steel rails. The mountain section is over 240 kilometers long. That is 19,200 tons of steel rails alone. Add to that the steel for the bridges, the locomotives, the rolling stock. We are easily looking at over 50,000 tons of material. We have already established that a mule cannot carry a single rail. But let's pretend they could drag it. To move 50,000 tons with mule teams that can haul, let's be extremely generous, 1 ton each, requires 50,000 mule trips. That is just to get the material to the base of the mountain. From there, the journey slows to a crawl. The round trip could take weeks. The number of animals required would be a logistical army in the tens of thousands. The feed required for them alone would be another 100,000 tons. The math doesn't just bend, it shatters. The numbers reveal that the project, as described by the official historical record, is a fantasy. The timeline, the available manpower, and the documented technology do not align with the sheer volume of work required. We are missing a variable in the equation. When faced with such a profound contradiction between the physical evidence and the official narrative, we must construct a new hypothesis. This is not a search for a fantastical explanation. It is a search for a rational one that fits all the available facts. The core problem is one of force and technology. The work accomplished required a level of energy and precision that was seemingly not available. Our hypothesis must address this directly. So, let us propose this. The construction of the Trans-Andean Railway, and other similar projects globally, was accomplished using a form of technology that was not publicly known, and was deliberately kept secret. What could this technology be? It would need to solve the primary problem: the removal of massive quantities of hard rock, quickly and efficiently. This could be a chemical process. A substance that could break down the crystalline structure of granite, making it soft and easy to remove with simple tools. This would explain why the photographs show men with pickaxes. They were not doing the primary work, but merely cleaning up after the real process was complete. It would explain the clean, almost melted look of some of the rock cuts. Alternatively, it could have been mechanical. Perhaps a form of tunneling machine far more advanced than the primitive steam drills of the era. A machine that could be disassembled for transport and reassembled at the worksite. Its existence would have been a state or corporate secret of the highest order, explaining why it never appears in photographs or public records. This controlled hypothesis also explains the global pattern. The technology was owned and deployed by a single, powerful entity. A transnational corporation or a consortium of industrialists who held the patent on this revolutionary process. They would sell the finished product, the railway, to governments, but never the means of its creation. The official local construction companies would be partners, or even fronts, providing the labor and managing the public-facing aspects of the project, while the secretive technical teams did the real work. This explains the identical construction styles across continents. It explains the missing records, which were never kept by the local company to begin with. It explains the impossible logistics, because if you can tunnel through a mountain 10 times faster, your entire project timeline shrinks, and the logistical strain is dramatically reduced. This hypothesis is unsettling not because it involves aliens or lost civilizations, but because it suggests that our own, relatively recent, industrial history has been deliberately falsified. It suggests that powerful groups possessed technologies a generation or more ahead of their time, and that our understanding of the 19th century is fundamentally incomplete. We are left with a simple, stark conclusion. The story we are told about the Trans-Andean Railway does not withstand scrutiny. The visual evidence shows work that does not match the tools. The logistical requirements are impossible to meet with 19th century transport. The official records are a hollow shell, devoid of the necessary detail. And the numbers, when calculated, prove the official timeline is a fiction. This is not an attack on the bravery of the men who worked and died on that mountain. It is an indictment of a historical narrative that has been fabricated to conceal a more complex truth. The railway is real, its presence is undeniable, but the method of its creation remains a profound mystery. What we have uncovered is not an answer, but a deeper set of questions. What technology was used? Who possessed it? Why was it kept a secret? And what other parts of our accepted history are built upon a similarly fragile foundation? The world around us is filled with monuments from the past, structures that we are told to accept without question. But true understanding does not come from acceptance. It comes from investigation, from applying simple logic and asking the hard questions, from refusing to accept a story just because it is the one we have always been told. Look at the old bridges, the canals, the tunnels, the great works of the industrial age. Look at them not just with wonder, but with a critical eye. Ask yourself, does the story make sense? Does the math add up? Often, you will find that it does not. And in that gap between the story and the reality, a hidden history is waiting to be found. If you find this line of inquiry valuable, you know what to do.